In this pre-algebra video, we're going to talk about Chapter 2, Lesson 4, Equations with a Variable on Both Sides. Our objective is, as the student, I can solve equations with the variable on both sides because I'll use my properties of equality to move them all to one side and then solve it just like any other equation. Now, imagine most of the equations you'll be seeing. So imagine you're solving an equation. You have one unknown. It's like you're on the farm and you're chasing just one chicken. Chasing one chicken is not so bad. You only have one target, one goal. And so when we were solving this equation, we had one target, one goal to get just that x by itself. But what if things get more complicated? What if you now had many chickens to chase? What if there was more than one? And let's be honest, they don't always stick together like that. Many times they split off in separate directions. One goes that way, one goes that way. Now all of a sudden you're trying to chase two chickens at once. It's very complicated. Unless, of course, you had a helper like this here tiger ready to swoop in and give you a hand. So unless you have help, you're all on your own. So an equations like this will look something like this. So equations with more than one quote unquote chicken, it means you're gonna have more than one. You're gonna have your variable in more than one spot. You don't get to chase just once. So you're going to have to chase many. So now our strategy we talked about, we mentioned it last year, is we're going to create a mutant chicken. Rather than chase two chickens at once, rather than chase a bunch of chickens all at once, we're going to take them all, we're going to shove them all together into one giant chicken. That's what we're going to do. So we'll have only one chicken to chase. Yes, that's my chicken. So yes, that's right. You heard me say it. Make a mutant chicken. Rather than have to chase more than one chicken at once, take your two chickens and shove them together so you have one mutant chicken so you can chase them. And here's what I mean. I'll explain how to do this in a minute, but essentially it's going to look like this. You're going to take your equation and you're going to do something to it. You're going to move your x's all to one side. And I'll explain why and the priorities in a minute, but I just want to show it to you. So if we did that, we would have 3 equals 1x minus 1. And now, ignore what we started with. You'll admit, what we have right here, that's a two-step equation. Well, in this case, it'll end up being a one-step, but it's basically a two-step equation that we know how to solve. So in one fell swoop, we turned this tougher-looking equation with a variable on both sides, and one fell swoop, we changed it into a regular two-step equation that we've been solving all of Chapter 2. So that's what we're going to talk about here. We're going to talk about how to prioritize and use what I've called the mutant chicken method to help us prioritize how to start these questions. Because you'll notice this bigger, scarier question simplified down to this, and it looks just like the question we had up here. That's what we're basically going to be doing. Let's do some examples. So the first example, there's only one chicken or x to chase, and the second one, oh no, there's now 2. But we're going to stick them together and it's going to look just like the first one. Alright, so before we do an example, let's take a look at some steps. These are the general steps when solving equations with the variable on both sides of the equal sign. So your general steps are the following. First things first, simplify both sides of the equation. Meaning, if you have parentheses, get rid of them any way you can. Whether you simplify or combine, whatever you need to do to get rid of parentheses. For our purposes, most of our questions in our section are going to already be simplified. Step 2, you're going to move the smaller variable towards the bigger one. Now, technically, this is not required, but the mutant chicken method tells us if the first thing we're going to do is combine our variables, but by the way, you could do that until you simplified. The first thing we're going to do is combine our variables. If you move the smaller one towards the bigger one, you can avoid having a negative variable, which would give you an extra step to have to worry about. I'll show you what I mean about that in a minute. So number 2 is not mandatory, but in general, you do yourself a favor. You get to save a step at the end. And usually less work. And then finally, once you've combined your variables, you'll just solve it like usual. It'll look like a regular question. Such as in this example, we did one thing to both sides, and look, we were left with a regular question that we know how to solve in one fell swoop. So that's generally what we're going to be doing in each of these examples. So these are your steps. Take a moment to copy them down. Okay, take a look at this example. We have 4x minus 9 equals 6x minus 13. I'm going to show you what I mean. Let's say you just move the bigger one towards the smaller one. So I'm about to do it in a way that I don't think is the fastest way, or sometimes it requires more work, but I'm going to quickly just show you how to start it. So you don't necessarily need to write this. I'm going to erase it and write it a different way. You could subtract 6x from both sides. Oh, by the way, if you're moving positive 6x to the other side, okay, that means you're moving a positive over, you do the opposite, which is negative or minus. So we're going to minus 6x from both sides. So if we do that, you'll be left with, on the left side, negative 2x. And on the right side, yeah, those would cancel. But now look, you now have a negative to have to worry about and keep track of. So that gives you extra work. Or if you'd started off by following the recommendation, move the smaller one towards the bigger one, the smaller one is 4x. It's positive 4x, move it by subtracting 4x for the same reason I just said for the other one. So subtract 4x from both sides, and now look what happens. They cancel on the left still, but now on the left, look what you're left with. On the left, you have negative 9, not regular 9, negative 9, because of that minus sign. So negative 9 equals 6x minus 4x, well, that's 2x. Minus 13 just drops down. Now notice, you now have a positive coefficient in front of your x. You no longer have a negative to have to worry about later. So it saves you effort and gives you less work to do. So now solve from here like a regular equation. Move the minus 13, then move the divided by 2. Make sure you can still do that. And understand why. And look at our previous videos if you're still not quite sure. And you end up with x equals 2 is what we end up equaling as the answer to this question. That's the value that'll make it true. And if you're not sure, feel free, plug it in. If you did that, you would end up with putting, let's say, a 2 right here and a 2 right here. So 4 times 2, well, that's 8. 4 times 2 is 8, so we have 8 minus 9. Well, that's negative 1. Now on the right side, if we put a 2 right here, we have 6 times 2. Well, that's 12. So we have 12 minus 13. 12 minus 13, well, that's negative 1. And so you're left with negative 1 equals negative 1. Well, hey, that's a true statement, so it checks out. X equals 2 is our correct answer. All right, so take a look at this example. Let's see if you can do this one. Hit pause and give it a shot. Alright, so the mutant chicken method tells us rather than chase down 2 chickens at once and worry about them running further and further away from each other, we're going to combine them right away. Ideally, you should be moving the smaller one towards the bigger one. This one is smaller, not because the 2 is smaller, because the very fact that it's a negative coefficient is going to be smaller than 6. So even if this was a negative 8 over here, negative 8a is still smaller than positive 6a, so because it's further to the left on the number line. That would be the one we were moving. So if that was negative 8a, we would start by adding 8a to both sides. But since it's just negative 2a, we're going to deal with it that way. But I want you to know the fact that the 2 is smaller isn't why. It's the fact that it's negative 2. Anyways, you move negative 2a to the other side by doing the opposite. The opposite of negative 2a is positive 2a, so plus. So you add 2a to both sides. They cancel on the left. On the left side, you're left with negative 9 equals 6a plus 2a. Well, that's 8a. Then we have plus 15. Now from here, it's a 2-step equation. It should solve a lot like the ones you've already seen. Take a moment to make sure you can solve it. Divide both sides by the coefficient, and you'll be all done. And you end up with a equals negative 3. So this was another example of solving an equation with the variable on both sides. Give this one a shot. See if you can answer this one. And if you haven't hit pause already, I'll give you a hint. What's going to happen is if you do the mutant chicken method, you move the smaller one towards the bigger one. Notice, if you move 2e, you're going to have nothing left on the left side. You're going to end up emptying the left side of the equal sign. If that happens, if you empty the left side of the equal sign, there's a 0 still there. So let me show you what that looks like. If you subtract 2e from both sides, they cancel on the left. But on the left, there's nothing else there, so you have 0. And on the right side, 4e minus 2e, well, that's 2e. You still have minus 16. Now, if take it from here, you're going to add 16 to the other side, then divide both sides by 2. That's one thing you could have done. Or, if you had preferred, you could have started that off slightly different. You don't necessarily need to write this again on the right side, but I was going to show you. You could always have just moved the 4e if you're worried about making that side empty. And if you'd moved the 4e, it would have been slightly different. You would have 2e minus 4e, well, that's negative 2e equals now negative 16. Now, this equation will have the same answer as the last one, but you just have an extra work to do to deal with that negative coefficient. But it's the same thing. So you don't need to write that example on the right, but I wanted to show you another way of doing it if you're nervous about emptying out one side of the equation. Anyways, finish solving the one on the left. Add 16 to both sides. Well, 0 plus 16 is 16, so we have 16 equals 2e. Now finish dividing and you're all done. We end up with e equals 8. That is the answer to our equation. And we've got the same thing on the version on the right. If you had now divided both sides by negative 2, and negative divided by negative is a positive, 16 divided by 2, well, that's 8. Some people tend to ask, and we want to make sure we understand, where could I use this in real life? So here's an example. We're going to talk about gym memberships and comparing them. So rather than guessing and checking, we're going to be able to write it out precisely. So we have Green's Gym. Green's Gym charges a one-time fee of $50 plus $30 per session for a personal trainer. A new fitness center has just opened up, and they've got different rates. They charge a yearly fee of, it's more, $250 plus, but they're only $10 per session with a personal trainer. And the question you're asked is, for how many sessions will they be equal? Meaning, how many sessions will it take to where these two gym memberships are equal? So this is an example. You might be deciding what gym to go to. Maybe you're trying to compare and contrast costs so you can make a good informed decision. So here's what we're going to do. First, let's imagine these are two separate situations. I want you to come up with the expression that represents Green Gym. I want you to come up with the expression that represents the new fitness center. We're going to come up with those expressions because if we're asking when will they be equal, that literally is our equation. So let's start by coming up with those expressions. So for the first one, for Green's Gym, we said they are a one-time fee of $50, meaning $50 only happens once. So at one point, we're going to add $50. And then they're $30 per session, meaning $30 times the number of sessions, which means you're going to do $30 times the number of sessions. In this case, we could say X is the number of sessions. So for Green's Gym, their expression that represents their cost is $30 times the number of sessions plus that $50 one-time fee. That's the expression for Green's Gym. Now I'm going to write that on the next. I'm going to write that. You're going to write it below, but I'm going to write it on the next slide so we can get that a little more organized. All right, so Green's Gym is 30x plus 50, meaning $30 times the number of sessions with the personal trainer plus 50. Now, let's figure out the other gym. Let's figure out the new guys. I'm just calling them the new guys for something to call them. All right, so the new guys. They charge a yearly fee of $250, meaning it only happens once. So at one point, we're going to be adding $250. Now, it says plus $10 for each session, meaning $10 times the number of sessions. So $10 times the number of sessions. In the last example, X represented the number of sessions. In this example, we're using the same thing. The number of sessions is still going to be X. So I'm going to fill that in on this page. So that means the new guys, we just said, were $10 per session plus $250. So $10 per session, so $10 times the number of sessions, plus $250. So now these are the expressions for these two companies. But now our question down at the bottom in blue says, for how many sessions will their cost be equal? In other words, literally, if this is their expression, when will they be equal? Meaning, what value of X, meaning how many, because X was the number of sessions, how many sessions will it take for these two to be equal? That's what we're trying to figure out here. So in other words, we're going to solve for X. Now that we've gotten this far, it's literally, you're going to solve it using the skills we just talked about with the mutant chicken method, where we're going to move our variables to one side and we're going to solve it that way. All right, so take a moment. We're going to move the smaller variable towards the bigger variable. The smaller one is 10x, so that means we're going to move it by subtracting 10x from both sides. And now from here, they should cancel, and you should be left with a two-step equation. On the right side, we have 250. On the left side, 30x minus 10x, well, that's 20x, and then plus 50. You now have a two-step equation. Finish solving for x. So we end up with x equals 10, and x stood for the number of sessions. So that means 10 sessions. That means in 10 sessions, their cost will be equal. So that's how long it'll take for them to be equal. Now, take a moment to think to yourself, think critically. Which company would you choose? Like, why would you choose one company over the other? Take a moment to think about that. The thing that sets them apart is their cost after 10 sessions. At 10 sessions, they cost exactly the same. But now imagine, what would happen at more than 10 sessions? Well, at more than 10 sessions, the company that charges more per session, they're going to be higher. And then the company charges less per session, they're going to be cheaper if you're going to go more than 10 sessions. But let's say you're going less than 10 sessions. Let's say you don't want to commit. You're not going to do a lot. If you're going to do fewer, that means if you're going to do fewer than 10 sessions, you're going to want to go maybe with a different company. So if you're going to do less than 10 sessions, you're going to go with a company that's going to be cheaper. If you're not sure, plug it in. Think of a number. Let's say 5 sessions. Well, Green's Gym, 30 times 5 is 150. 150 plus 50 is 200. So they would be only $200. Whereas for the new guys, that'd be 50 plus 250, that's 300. So they'd be $300, where these guys over here would only be 200. So if you're going to go for less than 10 sessions, you want Green's Gym. But if you're going to go more than 10 sessions, you're going to want the new guys. So you have to decide. You got to decide which one of these guys you're going to be. If you're going to be the one going to the gym a lot, maybe you want to be choosing the one that's cheaper once you go past the 10 sessions. So you're going to choose the new guys. But if you're the one that's not going a lot, perhaps, you're going to be the one who's going to cost you a little bit different. Who, for example, you're going to go less than 10 sessions, so they're going to be your better value. All right, so I'm going to leave you with another of the final example, maybe two, because these examples are going to have fractions. So give these a shot. All right, so this is your example for you to try first. But I'm going to remind you, move the smaller one towards the bigger one to save yourself a hassle of negatives later. Take a moment to hit pause. Okay, so our smaller one is the negative 1/6 n, because the negative is always smaller than a positive. There's nothing in front of the other one, so we know it's positive. Okay, so we're going to the opposite of negative 1/6 n is positive 1/6 n, or in other words, add 1/6 n. Okay, so they cancel on the left side. So on the left side we have just 15 equals, now on the right side we have 1/6 plus 1/6. Well, 1/6 plus 1/6, that's going to be 2/6, and you might be thinking to yourself, okay, 2/6, I can simplify 2/6. 2/6 is 1/3, so 1/3 n. So we have 15 equals 1/3 n minus 1. That's the step we're at. So now it's a two-step equation. Add 1 to the other side, and then get rid of that rational coefficient by dividing and then multiplying by the reciprocal. Keep, change, flip. So now divide both sides by your rational coefficient, and if you're not sure how to do this, go back to the first section in this chapter where we talk about solving with rational coefficients. Remember how to divide by a fraction. You flip it, and then it becomes a multiply. You flip the one you're dividing by. So now multiply straight across, and you'll have your answer. Multiplying straight across, we get 48 over 1. Well, that just means essentially 48. So that means n equals 48. And in other words, n equaling 48, that is the value that will make the left side of this equation equal the right side of the equation. You've now solved this equation. Alright guys, so we've done several examples. We talked about the priorities of solving equations with a variable on both sides. Make sure you practice, make sure you show your work, and they turn into questions that are now two-step equations that you can solve. Take care.